more time than usual.
Yeah. Yeah. So we said it was easy, but wait until we see the quiz, right?
Exactly. So did you have any questions about part 2 on the preparation, or part 1, I guess?
Not really. I've been trying to like distinguish the difference between the, what is it, like the rule of large numbers, is that what it's called?
Mm-hmm.
And what was the other one?
The central limit theorem.
Yeah. How did you, like, how did you
So,
distinguish?
in my mind, there's not really exact definitions, just a concept base. So the central limit theorem, actually first the law of large numbers, the more observations you have, or the larger the sample, the more accurately it represents the whole population. So if you're studying the effect of something on women, and you take like 1,000 women, that's going to be fairly accurate for all of the women in the US. And so that's dealing with the law of large numbers. The central limit theorem for me is dealing with the shape on like a histogram. The more observations you have, the more normal or bell curve shaped it'll look.
Okay.
That's just kind of how I see it in my mind.
Okay. So one's dealing more with the bell shape, which is the central limit theorem, and then the law of large numbers. Basically, like the more numbers you have, the closer it will be to the mean of like population mean, I guess.
Yeah, exactly. That's a good way to
Okay.
think about it.
All right, that makes sense.
Yeah. Let me see if I had any questions. So the mean, when you're given the word problem, the mean equals the mean, right?
Yeah.
Okay. Seems fairly simple.
Yeah.
Those were all the questions I had.
Okay. Sweet. Awesome.
Shall we jump in then?
Let's do it.
All right. Let's start that quiz.
Okay, I gotta find it really quick.
No worries. Excuse me.
Okay. You ready for 3?
Yeah, I am.
Okay. All right. So when you are taking a sample size of 5, what is the shape of the distribution of means histogram when the parent population is right skewed?
Okay, maybe I was not prepared for the quiz.
Yeah, I heard. That's a really small sample size, isn't it?
Mm-hmm. I would assume so.
Because in the reading it said like a 30 is like when you're gonna get like an accurate
Mm-hmm. So it's
measurement,
probably
right?
going to be skewed then.
I imagine so.
I guess I could also look at the that little distribution thing that you had.
You could pull it up.
Yeah. So we've got skewed right, n equals 5. Let me do 10,000 of those. It looks like it's slightly skewed right. Well, not slightly. It looks like it is skewed right.
Okay.
Were you doing it on yours as well?
No, I need to jump back on BYUI.
I can actually do this, I think. Let's see. All right, do you see yourself now?
Yeah, nice.
All right. So this is a little applet here. And I did skewed, and this is right skewed. N equals 5, and I did 10,000. Let me just... Yeah.
All right.
So would you say that's right skewed since it's way over here?
I would say so.
Okay. See if I can. There.
That's kind of nifty.
Yeah, it's kind of cool. I just actually noticed it while I was waiting. All right, so skewed right for number 3. Is that what we're going with?
Sure. I mean, there aren't that many other options, so if we get it wrong, we can.
Yeah, definitely wasn't skewed left, that's for sure.
Yeah.
So when you were taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is skewed right?
So that would be normal, right?
Yeah, I would say so. I mean, that's what I would guess at least.
It's a large enough sample size, maybe?
Yeah.
Okay. Okay, so when you're taking a sample size of 5, what is the shape of the distribution of means histogram when the parent population is normally distributed?
That would be normal because it's normally distributed, right?
Yep, I think so.
Doesn't even matter the sample size for those?
Yeah, I don't think so.
Okay. Looks like this next one is the same thing when it's normally distributed, just for n equals 100.
So just normal?
Yeah.
Okay.
And then for 7, what would be the distribution of means or when would the distribution of means be normally distributed? Choose all of the correct responses.
One would be correct, right?
Yep, and I think 2 would be as well because it's also normally distributed.
Okay. And then 4 would be correct, right?
Yeah, that's what I was thinking. Because 5, it does matter about the size of the skewed. Perfect.
Which of the following gives the best explanation of the central limit theorem? So this one is dealing with shape, right?
Yes.
Okay.
And I think it's the last one.
Yeah, I can see that.
And the second to last one would be for the large number, law of large numbers, right?
Yeah. Yep. I think so.
Cool.
Hopefully that's the next question.
Nice. So use the following information to answer the next 4 questions. Let x be a random variable when population mean equals 10 and population standard deviation is 6. Suppose a sample size of n equals 36 is drawn from this population. What is the mean of the distribution of sample means?
Would that just be 10?
I believe so, yeah, because the mean equals mean. And then the standard deviation is 6, correct? Oh,
Yep.
wait.
Unless,
Is this where we bring in the equation?
maybe. So that's, the equation was population divided by the standard deviation, or the square root of the standard deviation. Is that right?
It is the standard deviation divided by the square root of the sample, or n.
Okay, I had it backwards.
Oh, okay. So we've got 6 times the square root. I got 1 for this.
That's what I got as well.
Okay. Regardless of the distribution of the population, the sample size is larger than 30. What would be the shape of the distribution of the sample mean?
Normal, right?
Yeah, I was about to say, this is what you were saying within being larger than 30.
Yeah.
What theorem would justify your response to the last question?
That one is the law of large numbers, right? Maybe? Maybe I'm wrong.
That's a good question. So the law of large numbers, the more observations in a sample, the more accurate the results should represent the population. And then the central limit, as the sample size, or n, increases and becomes large, wow, what does that say? Oh, the distribution of the sample means becomes approximately normal.
Okay, what was the second one you were reading? Was that the
That's the
central
central limit theorem.
That sounds
Okay, I'll give that one a shot. You remember whose turn it is to submit first?
Yeah, I can.
Okay. I forgot. I have a terrible memory.
Mm, 100%, 100%.
All right. Let me submit that.
What do I like to see?
First try. Let me make sure yep. Nice. And so that's that. I can upload the link this week if you want me to.
Okay, so I'll just send it to your email then.
All right, sounds good. Well, thank you for bearing with the technical issues on my side here.
Oh yeah, no problem. Thank you. Thanks for
Yep.
dealing with Princess headphones.
I enjoyed it. It was a treat. All righty, well, I'll see you on Thursday then.
Okay.
All right.